So today we'll be teaching in our Calc 3 course about our 2.3 dot product chapter.
And I'll be talking about 2.4 cross product.
So with dot product, we will begin with where we start with a vector u and a vector v, and in which we can have up to three properties. We can have u1, u2, and u3, which could be x, y, z, and then v1, v2, and v3, which would also be x, y, z. And when we're solving for a dot product, we multiply the properties of these vectors and add up the sums. And in this case, you would multiply u1 times v1 and then add that to u2 and v2 multiplied together, and finally same situation where we go u3 times v3, and that is how we will find our dot product. And with this comes four properties. The commutative property is your traditional dot product, u dot v, and that is exactly how I just explained it. The distributive property is where we add in an extra vector, and so now instead of a traditional u dot v where we added in a w, now we get a u dot v plus a u dot w, because we're multiplying this u into the v plus w. And now we also get to the associative property, which is very similar. However, we're using now a constant c, which is not a vector, it is a scalar. And that will be multiplied into our dot product, where we can get cu dot v, or which is the same as u dot cv. And then lastly, we get our magnitude, which would be if we were to use the dot product on the same vector twice. So if you did v dot v, it is the same as finding the magnitude of v. Okay, so for this example, we have these three vectors. Vector A, where our components are 1, 2, and negative 3. Vector B, where we have 0, 2, 4. And vector C, which we have 5, negative 1, and 3. Okay, and so in part A of this problem, we're simply doing a dot product of vector A and vector B. Okay, so we'll begin with the formula we have up here. A1 times B1. So we will have 1 times 0 plus A2 times B2. So we will have 2 times 0 plus A3 times B3, which we would get negative 3 times 4. And now all we have to do is add this all up. So this becomes 0, cross that out, don't gotta worry about it. This would become a 4 minus 12. And so the dot product of A and B would be negative 8. Now if we move down to part B, we have the dot product of A and B times the vector of C, okay? And in this situation, we already have what the dot product of A and B is, so we can just plug that in, which is negative 8. And now we're gonna multiply it by the vector C. So we will just plug in vector C right here, which is 5, negative 1, 3. And simple enough, we will just multiply this 8 across the three components. So negative 8 times 5 becomes negative 40. Negative 8 times negative 1 becomes positive 8. And negative 8 times 3 becomes negative 24. And this is our answer. And because we multiplied the dot product times a vector, our answer will come out a vector, because C is not used as a dot product in this situation. Okay, now we move down to part C of this. And in this component, we're multiplying a constant 2 into this entire equation. And another way we can see it is, because 2 is a constant, is we can just pull that 2 out to the front, and we can rewrite it like this. 2 times the dot product of A times C. So now we simplified this for ourselves. We can now take the dot product of C and just multiply 2 in later. So let's do that. So we would put 2 times, and now we'll do the dot product. A1 times C1, which is 1 times 5, plus A2 times C2, which is 2 times negative 1, plus A1 times C3, which would become negative 3 times 3, okay? And now we would just add all this together. We would get 2 times 5 minus 2 minus 9. And in here we will come out with negative 6, so you get 2 times negative 6, okay? And now the answer to 2 times the dot product of A and C equals negative 12, okay? And now lastly, we're gonna work on finding the magnitude of B. And so the magnitude of B will become just doubling, or not doubling, sorry, multiplying everything in this vector by itself. It's the same as the dot product, so you're gonna do B1 times B1, which is 0 times 0, plus B2 times B2, which is 2 times 2, plus B3 times B3, which is 4 times 4. And that will leave us with 4 plus 16, which equals 20. And that is every case that you can run into with the dot product.
For 2.4 cross product, this is our main rules that we will follow. So if you have one function of u, the next of v, for just our case, I know it's ijk, but for this case, I'm gonna use x, y, and z just so we can see the values. So this is a table that we were gonna use for the cross product. So, and this is called determinant form. So when you try to find the I of the cross product of u and v, we're gonna say this is the x portion. So to find the I, we cross out the I that's in our head, and then we do a little loop, and it's called a Hershey kiss. So you go that times that minus that times that. So at the end, for I, it'll be y1 times z1 minus y2 times z1. And this is just one way to look at the I. So same thing for the j. When we want to find the j, we cross out the j's, and it's going to be, we do the Hershey kiss. So it's going to be x1 times z2 minus x2 times z1. And these will just give you straight numbers. And also, at the end, you get your I, your j, and your k. But the j will always be negative. So it's going to go positive, negative, positive. And this is the formula for the cross product. For these two examples for 2.4 cross product, we have example 1. So it's going to be the cross product of u and v, which is a simple one. You have your u and your v. And then for example 2, I'm going to be doing the cross product of v times w, all of that times u. So this is just a different way. It's called a triple scalar product. So for the first one, I'm going to put my x, y, and z into my table. So for u, it's going to be 3, negative 1, 2. V, it's going to be negative 2, 0, 1. So now from here, I do my little Hershey kisses. So negative 1 times 1 is just 1, minus 0 times 2, which is 0. And then for j, cross out the j's. So now it's going to be 3 times 1, 3 minus negative 2 times 2 is 4, negative 4, so it's 2, and then that, minus negative 4. For k's, 3 times 0 is 0, minus negative 2 times negative 1, which is 2. So my answer right here, it just goes into this form again, just like up here. It's going to be 1. 3 minus negative 4 is 7, but then you got to remember your negative over here. -7. 0 minus 2, -2. And this is how simple it is. That's your answer. For example 2, we're going to do our cross product of v times u. So with this, the cross product is the x's and the multiplication is the little dot, which is the dot product. So we got to do v times w. So v is just jk. So now you got to pay attention to what your form is. So jk, we'll just get 1, 1, and then 0 over here. Your w's, I gets a 1, k gets a 1, no j, so it's a 0. So now just do our thing. 1 times 1 minus 0. J, 0 times 1, 0, minus 1. K's, 0 times 0 minus 1, so -1. So now we're going to get 1, and then this is just going to be -1, but then you got to remember over here, that's going to make it +1, and then -1 right here. So now we're not done yet. Now we got to incorporate our dot product with a u. So u is going to be the I and the j. So it's going to be 1, 1, 0. So now for dot product, now you just do the x times the x, y times y, z times z. And when I'm saying that, because over here I said the x, y, z, so it's easy just to keep everything in the same form. So now it's going to be, your end answer is going to equal 1, and then 1, and 0. So now that we have this, now we just go 1 plus 1 plus 0. The final.
So now that we finished our Calc 3 portions, now we're going to move into Chapter 3 of differential equations, and we're going to work on 3.2, real and distinct roots.
And then we're going to move on to 3.6 combined with 3.7, Wronskian and linear independence.
So the breakdown of real and distinct roots, we will begin with a equation where we have some constant a to the y double prime plus some constant b times b or y to the prime, and then some constant c to y, and this would be all equal to 0 because our equation needs to start with a constant coefficient. It must be homogeneous, which means it equals 0, linear, and has to have a second order differential equation, which is that y double prime. And from here, now we can rewrite our equation as instead of y double prime, we have a r squared. Instead of b y prime, we have b r. And then instead of cy, we just simply have c now. And now we equal it to 0 again. And from here, we will have to solve out our r's and set them where they equal 0. So we'll have to factor it out, or we'll use the quadratic formula to solve this. And step 3 is to use the two r's that we find. We're going to get r1 and r2, and that's how we will find y1 of t and y2 of t. And so in y1, we will get e to the r1 times t. And then y2, we'll get e to the r2 times t. And then lastly, we will get a function y of t. Not y1, not y2. A function y of t. And then we'll equal it to c1, which is our constant, which is the same as when we take an integral and we end up with a plus c at the end. This is factoring in this constant before anything. So we'll get y of t equals c1 times y1 of t plus c2 times y2 of t. And this is the exact same thing. The constant just gets plugged in before. And from here, we will end up taking a derivative of this function, and we will use our initial conditions that are given to us prior to starting the equation to solve out what these constants actually equal. Okay, in this example right here, we're given the equation y double prime plus 11y prime plus 24y equals 0. And then we're also given the initial conditions of y of 0 equals 0 and y prime of 0 equals -7, okay? And our first step is to make sure we have the right factors of our equation. And we have a constant coefficient. It is homogeneous because it equals 0. It is linear, and we have a second order differential equation. So now that we have that out of the way, we are good to move on to the second part. So our y double prime, because it's just, we can imagine a 1 in front, it becomes r squared. Plus, this 11y prime becomes 11r. Plus 24y, we just drop the y and it becomes a 24 equals 0. Okay, and the next step is to solve for our r's and find where this equation equals 0. So let's factor. First times the last, 24 up top, 11 down bottom, and right here we get 8 and 3, so r plus 8 and r plus 3 is what our equation factors into. And so our r becomes negative 8 and negative 3, okay? Right here. And it doesn't matter what we pick for R1 or R2. In this case, R1 for me would be negative 8 and R2 would be negative 3, okay? So let's set up our y1 of t. y1 of t equals, and remember our equation is e to the negative, not to the negative, scratch that, e to the r1 of t. So r1 is negative 8 times t. So that's our y1 right there. Now our y2, very similarly, equals e to the negative 3t, because we plug in our r2 there, okay? And so our initial equation, which is just our y of t, not our y1, not our y2, but our y of t, becomes c1 times y1, so we would just plug in e to the negative 8t plus c2 times y2, which is e to the negative 3t. So now that we have our y of t, our next step is to find the derivative of this so that we can plug in our initial conditions and solve for our constants c1 and c2. So the derivative of this equation the derivative of e to the x is 1 e to the x. So just essentially e to the x, but you have to multiply this negative 8 down bottom. So you get negative 8 c1 e to the negative 8t. Same goes for this. You multiply that negative 3 down, and it equals negative 3 c1 e to the negative 3t. So now we have our two equations to allow us to solve for our constants c1 and c2. Okay? And the easiest initial condition for us to plug in is our y1. Or not our y1, but our y equation, okay? Because our x is 0, and so is our y, okay? So let's just box this in so we have some room. Let's plug in our initial condition. So 0 equals, and anywhere we see a t, we're going to plug in a 0. c1 e negative 8 times 0 plus c2 e to the negative 3 times 0. And we should all know this by now, but e to the 0 is what this becomes. And anything to the 0 power becomes 1, so I'll just cross that out. It's not as, doesn't equal 0, we're just crossing out because we don't need it in there anymore. Hold up. All right, and now we just need to solve for one of our c's, right? And in this c, all we need to do is, let's rewrite it first, just so you get a better look at it. C1 plus C2. This is really what this equation comes out to. And I want to solve for my C1, and if you were to solve for C1, you get a negative C2. Because all we had to do was subtract over that C2 to get it by itself. Okay? So let's not forget this right here. And then I'll just scribble it as, use as much of the board as possible. Now, let's plug in our initial condition for our y prime. So y prime, anywhere we see a t, we will plug in a 0. And for the y prime of t, we just put in a negative 7. So negative 7 equals negative 8 c1 e to the negative 8 times 0 minus 3 c2 e to the negative 3 times 0. Okay, again, our e's just become 1. Let's cross them out. And our next step right here is, since we've already solved c1, let's plug that into our equation so we get 2 c2's, and now we can solve for c2 and get an actual answer for it. So negative 7 equals negative 8 times, and c1 is now negative c2, so negative c2 minus 3 c2. Okay. And now let's continue going. Negative 7 equals, and we all know this, a negative times a negative becomes a positive. So let's just re-envision this as a positive 8c2 minus 3c2. And what does that get? That gets us 8, I'm lying, 5 c2, because 8 minus 3 is 5, obviously. Okay. Now, last thing to do is divide over this 5. And c2 equals negative 7 fifths. Perfect. And we've solved our c2, but we still don't have our c1, right? So let's plug in our c1. c1 equals negative c2. What is c2? Negative 7 fifths. So negative times a negative, our c1 is now 7 fifths. Okay. Now I'm going to erase the top so we have room to answer this equation. But I will save that y of t because that's what we need. Actually, I'll erase it all because you see the work. We don't need it anymore. C1 equals 7 fifths. And C2 equals negative 7 fifths. And now, to answer our question, or our equation, let's plug in our constants. So y of t equals C1, which is 7 fifths, times e to the negative 8t, plus C2, which is actually a negative. So we can change this plus to a negative, since it's going to happen anyways. 7 fifths e to the negative 3t. And this is our final answer. Y of t equals 7 fifths times e to the negative 8t minus 7 fifths times e to the negative 3t. It's a long process. It's actually very simple once you get to know it, and very repetitive. However, this is how we solve for our real and distinct roots.
All right, to start off 3.6 and 3.7, we're given two equations, f of x and g of x. So when you get these equations, you put them side by side, and then at the bottom, you take the derivative. So the derivative of here is here, likewise over here. So your f of x top, g of x top right, and then your derivatives go right underneath. So to start off, we're going to start off with the Hershey kiss that I talked about earlier. So we're going to start by this times this minus this times this. So for this first one, and also your answer, what you're trying to find is if this function is independent or dependent. So it's dependent if it equals 0, and it's independent if it does not. So we're going to start off. We're going to go 6x times these. 6x plus 2 and ln of 6. And I'm not going to use any parentheses because these are all terms by themselves since they're all being multiplied. And we're going to go minus 6x ln 6 times 6x plus 2. So right here, we're going to take this whole thing minus this. So these are going to cancel, these will cancel, and these will cancel. So now we are left with 0, which means that it is dependent. Follow it up over here. We're going to do the same thing, but over here, there's no x's or ln's or anything. It's just these simple polynomials. So we're going to go 2t squared times 4t to the third, all minus 4t times t to the fourth. So now we're going to get 8t to the fifth minus 5t to the fifth. Because you add your exponents, and then you 2 times 4, and then 4 times plus times 1 over here. So now this is going to equal 3t to the fifth. So because this is not 0, that means that this whole function thing will be independent.
To recap today's lesson, in Calc 3 we covered the dot product
And cross product.
and in differential equations we covered real/distinct roots.
And Wronskian and linear independence.